So we got to solve this problem, and they want us to do it by completing the square. So here's how we're going to do that. What they mean by completing the square is they want us to rewrite this equation with something squared in it. So that way we can just like square root both sides instead of trying to factor. So how are we going to do that? So first off, let's remember just what the squared pattern is anyway. If we have something plus something squared, that's the one thing squared plus 2 times both of those things plus the second thing squared. So let's compare that to what we have here. So what we have here is x squared plus 5x plus 4. So look how we already have this x squared. So that means when we rewrite this as something squared, that first thing is going to have to be x. And then now we need to focus on this 2xy part. Because look at what we have here. That's the 5x part. So we know that we need this 5x to be the 2xy part. And then now if we look at that equation and cancel out these x's, we can tell what y has to be. To make this all work, y has to be 5/2. Just half of whatever that b term is. So we'll rewrite that as x plus 5/2. But then here's what we have to do now. Because think about, let's come over to the side, let's change colors. What is x plus 5/2 squared? Well, x plus 5/2 squared is x squared plus 5x plus 25 over 4. Because 5 over 2 squared. And so we're a little wrong right now, right? Because we want it to equal the top equation, but right now it equals that left equation. So here's what I think the best way to do that is. To say that right now what we have, this x plus 5/2 squared, that's that blue equation on the left. So to turn it into the thing on the top, we just have to get rid of that 25 over 4. And then add back on this 4 here. Because see what happens is if we highlight this section right here, this x squared plus 5x, that's the same as this thing right here. And you can look at that for a second. Remember this, that's like that minus 25 over 4 that we added, and are canceling those out. So that's how completing the square works. Notice here, there's actually a very nice, concise pattern that we can write. That, we'll leave this on the screen so we can compare. That if we have x squared plus b, x, we can complete the square there as x plus half of b squared. See, that's what we did, 5 over 2 squared. And then minus whatever that b over 2 is squared. And see, that's what we did, 5 over 2 squared. And so that's the nice completing the square pattern. I think whenever you're talking about completing the square, you should just remember that and just use that pattern. But it is important to understand where that's all coming from. And that's everything we just talked about. So let's go ahead and finish this equation out. So how should we solve this equation now? Well, I'd like to move these numbers to the right side. Or actually, should we multiply everything by 4? Get rid of the fractions? Might as well. So then we have 4 x plus 5 over 2 squared minus 25 as the 4's cancel, and then plus 16 because we're multiplying everything by 4. So now let's move all the numbers to the right side so we can take the square root. So what is that? Negative 25 plus 16 is 9, right? 9, negative 9. And then we're going to add that to the other side, so it'll be a positive 9. And then we're going to divide by 4. So x plus 5/2 squared equals 9 over 4. Okay. Well, now, just like the problems previously, we need to square root both sides. And always remember the plus or minus. So x plus 5/2 equals negative. There's square root of fractions, square root the top and bottom, negative 3/2. And x plus 5/2 equals positive 3/2. So x equals negative 8/2, which is negative 4. And x equals negative 2/2, which is negative 1. And there's the two answers. By completing the square. So, of course, this problem you could have just factored, but they wanted us to complete the square. So, critically, this is the completing the square pattern. That's the most critical thing. So, completing the square, you're rewriting the equation as with like the something squared in it, with the x just being in the squared. And that's nice because it allows you to square root both sides and solve the equation. And this is primarily used when you can't factor, because you can do this to any quadratic equation, whether you can factor or not. That's why it's so nice.